Hi guys, good morning. Happy Asynchronous Wednesday. Hopefully you guys are going to enjoy the nice weather that I think we're gonna have. I know it's a little cold, but it's okay. It's gonna be sunny out. I know some of you have work and some of you just enjoy getting to sleep in a little bit, but today we are going to start off and introduce our next unit. We do have 2 more units left of the school year. And so this is going to be our first functions unit, and then the second functions unit will come in about 2.5, 3 weeks. So as you can see, we do kind of stick with functions and talk about the different parts and components to functions for the rest of the school year. So in order for us to feel really good about transformations and their graphs of functions, we do just want to go back and review some of the basic parent functions that we're going to be talking about in this unit. We have the quadratics graph, we have the absolute value parent function, we have the cubic parent function, so something like x to the third power, and then we also have the square root parent function. So this video is going to focus primarily on the quadratic parent function. You'll notice that each section of these notes has its own video. So here's the first one. So if we think back to Algebra 1, we spent all of second semester talking about this quadratic, okay? Anything raised to a power of 2. We know it is this parabola shape where we know the vertex is down below that minimum value or maximum value, depending on if it's concave down or up. We know that we are given its inputs and outputs, and we don't really get them from any magical number. It really is simply just squaring whatever x is. So if we start here at 0, well, 0 squared is just 0. If we head down to 1, 1 squared is, excuse me, 1 squared is 1, right? 2 squared is 4. And then we can also go in the opposite direction and say, okay, well, if I have 1 squared, negative 1 squared, 2 negatives make a positive, so our value is still just 1. And then as we keep going up, we see that all of these values end up being positive, right? This graph of the quadratic. And then if we plotted those points, go over 1, up 1, over 2, up 4, over 3, up 9, and so forth, right? Over 1, up 1, over 2, up 4, over 3, up 9. And because there is no shift, there's no compression, there's no stretch, we can use that idea of saying, okay, we're starting here at our vertex. We'll go over 1, up 1. We'll go over 2, up 4. And then we'll go over 3, up 9, and so on and so forth. And that really is something that we talked about in Algebra 1 for a very, very long time. So we should feel pretty good about this. If we're talking about key points on the parent function, we know that its vertex is 0, 0. It always starts at the origin. We know we go up to 1, 1. We keep moving over to 2, 4. And then we know on the flip side, we can head over to negative 1 and go up 1. And we can head over to negative 2 and go up 4. So these key points of the parent function will always be there. Now, if there is an a value, if there is this vertical stretch or shrink, if there is this horizontal compression, then obviously these values are going to change. But if we are just talking about f of x is equal to x squared, the parent function, these are those key points that we see. Now, it's always important to talk about domain and range. Little refresher, domain are our x values, range are our y values, or in this case, if we're talking about functions, f of x, right? And in parabolas, we know that our domain is always all real numbers, right? Negative infinity to positive infinity, talking about interval notation. And then if we're looking at range in the parent function, nothing's really going on past where y is equal to 0. There really are no negative values for y. So we can say that y starts at 0 with our closed bracket because no point can be underneath 0, less than 0, and it heads to positive infinity. And remember, positive infinity is with a open parentheses because it is unknown. And if we think back to Algebra 1, we would have written it as y is greater than or equal to 0. So this was just a little refresher on the quadratic parent function. Go ahead and look at this next function that you see the absolute value. Click on the video and learn more about that.